Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage, Glen Ellen, Illinois. This video today is going to look at Day 9, Festivities, the Advent of Code 2020. My solution, as I've come to know it, is always going to be in Python. So, encoding error. So basically I have a list of numbers, and you can look at it here and just pull up this number here. You have a list of numbers, and basically in this example you're like, okay, for a given number in here, let's just say 62, do any of the previous 5 numbers, any combination of 2 of the numbers add up to 62? And you go, yep, 47 and 15. So yep, that's true. And then you would go to 55 and you go for the previous 5 for that, and you would go for that, and you would go for 62, yep, 47 and 15. Then for these, 1, 2, 3, 4, 5, 55, 40, and 15. And the goal for part 1 is to go until you find out that a given number in a certain number of entries prior to it, you can't find a single instance where 2 of the numbers add up to the number that you're looking for. So that's what we're going for part 1 at least. And so you can say here, this is the function that pretty much does all the work. For a given index, and for preamble, how many previous values before it, go through and range, start at index minus preamble, and go up and try every combination of values. And if you do find out that the I value and the J value inside of the list, they add up to the index, the value that you're looking for, then you return true. So like saying, we don't care which indexes for this one, for part 1, but we do care that we found it or not. So again, 1, 2, 3, 4, 5. So 40 would come up, or was it 40? Is 15 and 25. And they said that one of these down here does not come up true. 127 for the previous 5 numbers. 1, 2, 3, 4, 5. None of these add up to 127 because 95. The smallest 2 numbers already go overboard. And so that would be the first, in this 127 in our example here, in this example, would be the first case, the first number that comes up false. So the case was for this giant data set with numbers that go up way beyond 32 bits, you have to use long longs for these things. Like, what is the first digit, or what is the first number that comes up false? So I just open the file, take the strings in, convert them to integers, and then basically just start at index 25, looking at the previous 25. If it comes back valid as true, just go to the next index. Try again, try again, try again. And I know I'm going to need that value for part 2, so I just print out, and the answer comes out to be 133015568. Comes up as the number in in our list here. That is the first number. We're at 133. Just the hard part's finding it here, because it's how big is that number? Come on. Are we getting anywhere close? 133. Anyway, I guess I could do a search for this. Find value, find next. Oops, got to go up, I guess, instead. There's that number. So that's the first number, about halfway, 2/3 or 60% down the list. That's the first number in the entire list that any of the previous 25 numbers can't sum up to it. So that takes care of part 1. So then part 2 says, okay, so why don't we find out, okay, what numbers, or a list of numbers that sum up to this 133, and you can see the answer here already. I gave it away, but that's okay. I'll just run it then. What the hell? 161,07959. So what are you doing here? You're going through, and basically I'm going through starting with the 0th number, and what I'm doing here is just checking to see if because it's contiguous range. So I'm starting from the 0, and I'm going to keep counting up. And just contiguous order, and if any of them, like from the 0 and the 1, or the 0 and the 2, like this, it's a 35 plus 20, or 35 plus 20 plus 15. And again, I know this isn't the most efficient thing ever, but what it's doing then is just summing up and just going, oh, that's 55, okay, that's 70. And if any contiguous block of numbers sum up to that search value, the 133 number I'm looking for, 133015568, then I'm just going to print out the solution and break out, because they tell me there's only one solution. I guess I don't technically need, do I technically need that break? No, I don't technically need that break, because it just brute forces every possible combination to see if any contiguous blocks of numbers sum up to my 1330. And in this case, they're saying of that range, so so like of that range from low to high, because of that contiguous block, what is the smallest value in that block? What is the largest value in that block? Add the two numbers together, and that's how you get your solution. And so that pretty much covers it. I'm talking pretty fast today for some reason. I don't know, but that's no big deal. But again, I always say this is going to be my last one, but I end up dragged in again because these things are so much fun. I'm having a ton of fun learning Python and just trying out and all this, just learning all these things I've never done before. And so just, like substrings or subsets of numbers and sums of substrings of numbers and stuff like that. And again, I know there are more efficient ways to go about solving the problem, but I found a solution for now. I'm happy with it. Life is good. Ready to move on to day 10 tomorrow. As always, thanks for sticking with me. If you have any questions, swardb@cod.edu is a great way to get a hold of me, or comments here. And if you can't get your code to work, just remember I'm working. I don't know if it matters for anything. I'm working on version of, not Thani. I'm not looking at Thani's code. I'm looking at Python 3.7.2. Maybe you're on Python 2. I don't know, but I know it works on my machine, and that everything has worked on my machine because I've proven it to you day in and day out as I go through. Anyway, I'm going to stop blabbing, go on with my life here, and I hope you do too. Have a great day, everybody. Take care. See you.